This is Geometry, Lesson 4-5, Congruence in Right Triangles. In this lesson, we'll be able to identify congruent right triangles. Let's look at critique and explain. Seth and Jay wrote the following explanations of why the two triangles are congruent. Seth says there are two pairs of congruent sides, AB and DE, that are congruent, and AC and DF being congruent, and a pair of congruent right angles, C congruent to F. So triangle ABC is congruent to triangle DEF by SSA theorem. J, however, says that the lengths of BC and EF are 3 inches. Since these are 3, 4, 5 right triangles. Ooh, you didn't learn this yet, but you'll learn this yet later. There are 3 pairs of congruent sides, AB congruent to DE, AC congruent to DF, and BC congruent to EF. So triangle ABC is congruent to triangle DEF by SSS triangle congruence theorem. Okay. So part A, do you think either student is correct? Do you think any of these students is correct? Okay, notice, try to reason out yourself. Notice what's the same about triangles ABC and DEF and what's different. Right, the sides AB and DE are the same length, AC and DF are the same length, angles C and F are both right angles, ABC is sitting on one of its legs, but DF is sitting on its hypotenuse. Okay. So what postulates or theorems can you use to prove that two triangles are congruent? So far we learned SSS, SAS, ASA, and AAS theorems, right? So first of all, is J correct when he says that BC and EF are 3 inches? Yes, you can use the Pythagorean theorem. This is hypotenuse, right? So using the Pythagorean theorem, you can say, oh, BC squared plus 4 squared square root is equal to 5 squared for this one, right? And same thing for here. 5 squared is equal to 4 squared plus EF squared square root. So BC and EF should be the same even without solving them, right? They must be the same number. So what do you think? Who do you think is correct, or do you think both are correct or none of them are correct? Okay, although Seth's conclusion is correct, okay, the triangles are congruent, but did he use the valid criteria? Is this really SSA? We do not have SSA triangle congruence criterion. There's no such thing as SSA. Okay, so you need to use either SSS, SAS, ASA, or AAS. So let's write that down. We got SSS, SAS, ASA, and AAS so far. SSA is not the right congruence criteria. Okay. So let's explain that. Although Seth's conclusion is correct, he used invalid criteria. Okay. J uses valid criteria, and his conclusion is also correct. And his conclusion conclusion is correct. Okay. So, part B. Describe when you can say that two right triangles are congruent if you are only given two pairs of congruent sides and a right angle in each triangle. Anytime you're given two right triangles with two pairs of congruent sides, you can find the lengths of the third side using the Pythagorean theorem like Jay did. And you can show that the triangles are congruent by SSS, right? All right. So think about this question. If the lengths of both legs were given instead of the lengths of one leg and the hypotenuse, could you show the triangles are congruent? Yeah, it should still be possible because you can use SAS or use SSS after you find the length of the third side. So no matter which two sides you have for the right triangles, you can figure out the third side using the Pythagorean theorem, okay, as long as you have the right triangles. So in this lesson, we're going to think about what minimum criteria are needed to show that right triangles are congruent. We might have much information and more than enough information, but what would be the minimum criteria to show the triangle congruences? Let's look at example 1. Investigating right triangle congruence. When any two pairs of corresponding sides are congruent, can you show that two right triangles, ABC and DEF, are congruent? Explain. So we got two right triangles here. And we got two pairs of corresponding sides that are congruent. So just like we talked about earlier, if we have two legs that are congruent, we can figure out the third side by using the Pythagorean theorem. And we'll figure out that the third side is also congruent or not. And then we can use the congruence criteria we have, SSS, SAS, ASA, and AAS, right? So can you show that two right triangles are congruent when any one pair of corresponding acute angles is congruent? And any one pair of corresponding legs is congruent? Explain. Okay, so imagine we have two right triangles and any one pair of corresponding acute angles congruent. Any one pair of corresponding legs is congruent. So any legs, these two or these two, right? This one. Can we prove it or not? Well, there are two cases. If the congruent legs are included between the congruent acute angles and the right angles, so if we have these two legs that are congruent, then the triangles are congruent by ASA, right? If the congruent legs are not included, we have AAS. So no matter what, we have two angles and a side that's congruent. So no matter if it's a right triangle or not, we already know it's a, no matter which angle or which side it is, we have one additional information because they're right triangles, right? We already have two angles and a side. So we can use ASA or AAS. Yes, we can use ASA or AAS because we already have the right angles as information given. Okay. So we have two angles, two corresponding angles that are congruent and one corresponding angle that are congruent, one corresponding side that are congruent. So hypotenuse leg theorem is another special theorem for right triangles. If the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay. So if we know these hypotenuses are congruent, and the other leg is congruent, maybe B, then only for right triangles, then the triangles must be congruent, is the hypotenuse leg theorem. We're going to use the hypotenuse leg theorem in example 2. Example 2. Ashton is washing windows using a 10-foot ladder. For the first window, the ladder reaches the window when he places the base of the ladder at the rose bush. How can he determine where to place the ladder to be sure it reaches the last window? So he wants to place it exactly the same way, right? The ground, the ladder, and the side of the house form a right triangle because the house should be perpendicular to the ground. And we can name that triangle RAH. When Ashton moves the ladder, there will be another right triangle SBK. Ashton wants AH to be equal to BK because the windows are on the same height. If the two triangles are congruent, then he knows AH should be congruent with BK by CPCTC. So we can prove the triangles are congruent first, and then we can make sure that the heights are the same by CPCTC because they're the sides of the two right triangles, right? So if RH is equal to SK, then the triangles are congruent by the hypotenuse leg theorem. So then we can conclude that the ladder will reach the last window. Let's look at try number 2. What information is needed in order to apply the hypotenuse leg theorem? Okay, in order to use hypotenuse leg theorem, we need a hypotenuse. We need one pair of legs to be congruent. Okay, we already have a hypotenuse here. And we have a leg here, but we need both of them to be congruent to the corresponding sides. So what are corresponding sides? We need MN is corresponding to QR. So we need this length to be 5. We need PR to be 9. So those are the information we need. MN should be 5 and PR should be 9. Then we can use the HL theorem to prove that these two right triangles are congruent. Let's look at example 3. Write a proof using the hypotenuse leg theorem. Okay, let's write a proof to show that the triangle is isosceles. We're given these congruent sides and right triangles here. Okay, we got a lot of triangles inside those triangles. We have to prove that triangle ABC is isosceles. ABC, the whole big triangle is isosceles. In order to prove that, we need to prove that two sides of this triangle are congruent. So we need to prove AB is congruent to AC. And that's what the last step will be. AB congruent to AC. And then by definition of isosceles triangle, we can prove that triangle ABC is isosceles. Okay, that's the goal we have. Let's look how we can start with. We always start a proof by given information. So we know that the lines are perpendicular and some congruent lines. So FD being perpendicular to AB is given, which means they have a right angle. FE also perpendicular to AC, which means we also have a right angle over here. Right? And by definition of perpendicular angles, we know that measure of FDA and FDB are 90 degrees, FEA and FEC are 90 degrees. And by definition of right triangle, these triangles are all right triangles here. And we're given that AE is also congruent to AD. And then we know that AF is congruent to itself by reflexive property. It's congruent to itself, right? And then by HL theorem, we can prove that FEA and FDA are congruent triangles. And we can say by CPCTC, EF and DF are congruent now, okay, by CPCTC. And now using the given information again that FC is congruent to FB, we're going to use the HL theorem again to prove these two right triangles are congruent because those are right angles as well. And then we're going to say by CPCTC, angles ECF and DBF are congruent as well. Okay. And then by converse of isosceles triangle theorem, AC is congruent to AB, definition of isosceles triangle theorem, ABC is isosceles. Okay, so do it step by step, we'll be able to prove what's given. Let's try number 3. Let's write a proof to show that these two triangles are congruent. All right, work on it, think about it, come back when you're ready. So remember when proving, you can either use the two column proof like we just did in example 3, or we could do a paragraph proof, or we could do a flow proof where we have a flow chart. Okay. So I'm gonna use two column proof as well, which means I'm gonna write statement on the left column and reason on the right column. Okay. And so my first statement is going to be stating the given property. Right. So we're given JL is perpendicular to KM. So and also JK is congruent to LK. Okay. And so let's say JL perpendicular to KM is given. And using this perpendicularity, we're also going to say JKN and the measure of JKN and measure of LKN are 90 degrees by definition of perpendicular angles. So let's abbreviate. Okay. And then, so they're right angles. And then, what else can we do? That we need to prove JKM. This big triangle is congruent to LKM, another big triangle, another half triangle, right? So we have a side, we have the right angles. That's all we have. What else can we do? Okay. First, we're gonna use that KN is congruent to itself. The fact that it's congruent to itself by reflexive property of congruence. Then we can say that J and K. So we can say that J and K is congruent to L and K because all right angles are congruent. Okay, so we can say that triangles JKN and LKN are congruent by the HL theorem. And after that, that's not the end because we want to prove JKM and LKM congruent. So we're going to keep going. KM is also equal to itself by reflexive property, right? JK is congruent to KM JK is congruent to LK by the given information. Now we're going to use the second given information. And then we're going to say that angles JKN, JKM, and angles LKN are congruent by CPCTC, right? But really, JKN is really JKM, right? So we have the angles that are congruent now because the two triangles are already proven that they're congruent. So by CPCTC, these two angles are congruent as well. And we know that by reflexive property, KM is congruent to itself. So we have SAS theorem. So now we can say JKM is congruent to LKM by SAS theorem. Okay. And remember that in order to use HL theorem, the triangle must be right triangle, but JKM and LKM are not right triangles. So you can only use it to prove the right triangles here. And then use the BCDC to prove that bigger two triangles are congruent. Okay, that was our lesson. 4-5, congruence of right triangles. Okay, let's summarize our lesson. So we have 4 theorems plus HL theorem to prove the two triangles are congruent. So for right triangles, we can use SAS, ASA, AAS, and the HL theorem. Those are commonly used theorems to prove right triangles are congruent. Okay, that was our lesson. We'll continue with our next lesson in the next video. Bye.